Using a verification framework can dramatically improve the quality of our designs. However, setting up a verification framework from scratch can be quite daunting. Luckily, there are open-source libraries that handle most of the infrastructure required for creating, running, and managing our tests, so that we can focus on the parts of our test bench that are unique to our design and add value to our development process. In this video, we will set up a minimal verification environment with VUnit. Our test bench will include verification components for driving and monitoring an AXI-Stream bus. VUnit is an open-source unit testing framework for digital systems design with VHDL and System Verilog. It provides the infrastructure for creating and managing verification environments so we can focus on writing meaningful tests. At its core, VUnit provides a Python-based test runner that manages our test cases, handles compilation dependencies, and produces structured test reports. In addition to automating the simulation runs and test management, VUnit also provides several libraries to help write our test cases. These libraries include verification components, logging mechanisms, check procedures, and randomization. By leveraging these pre-built components, we can make the test case creation process more efficient, less error-prone, and more enjoyable. There are two prerequisites for using VUnit. We must have a supported VHDL simulator, and we must have a Python installation, including a package manager and a tool for creating virtual environments. VUnit supports several simulators. A comprehensive list can be found in the project's documentation. For this example, we will use GHDL. In Ubuntu 20.4, we can install GHDL using the Snap Packet Manager. Once we have our simulator, we can install the VUnit Python module. The recommended way to do this is within a Python virtual environment. We can do this from the terminal by moving into the folder where we'll run our simulations and using the commands shown here. We are now ready to create our verification environment. A VUnit verification environment includes at least two files, a test bench and a simulation script. This is what a VUnit test bench in its simplest form looks like, as described in the VUnit user guide. We must pair our test bench with a simulation script, which in its minimal form looks like this. We can then run the simulation script from the command line. The terminal output confirms that the test was run successfully. Line 4 shows the location of the file where all the messages in our test bench are logged. Our test case executed a single statement, printing "Hello World" to the output file. VUnit includes verification components with support for several standard interfaces, including AXI-Stream. To get started, we include the Add Verification Component statement in our simulation script to add support for the verification components. We can now expand our existing test bench by adding one AXI-Stream master and one AXI-Stream slave verification component. First, we add all the signals and constants that we'll use to configure and connect the verification components. Then we can add the verification components themselves. We are now ready to generate and capture data over the AXI-Stream bus. To do this, we must expand our main process to start the data transmission and reception in the AXI-Stream verification components. At this point, we can simulate our expanded test bench. Because I'm using GHDL as my simulator, I'll include an argument that creates a VCD waveform in the simulation script. Finally, we can see the results of our simulation. For this example, I'm using Surfer as a waveform viewer. Surfer is a VS Code extension, which allows us to visualize our waveforms without leaving the code editor. Zooming in at the start of the simulation, we can see that the valid and ready signals of the AXI-Stream bus are toggled by the verification components. For this, they use the parameters we set when we declared the constants for the AXI-Stream master and slave interfaces. In this video, we created a minimal simulation environment with VUnit that included driving and monitoring AXI-Stream interfaces. We started with a minimal VHDL test bench and a Python simulation script, which we used to create a bare-bones simulation. We then expanded the simulation script to include the VUnit verification components in our environment and added the logic required for instantiating, connecting, and using the verification components in our test bench. Finally, we ran our simulation and confirmed that our verification environment worked by inspecting the generated waveform.